Hi everyone, hope everyone here is having an amazing BlockJam. And in this session, I want to go ahead and dive into a little bit about how you can simplify your Web3 game development journey. My name is Vasanth, I'm from FusedVR, and really quick before we dive in, let me just give you a quick overview of what FusedVR is. It is a community of game developers that we've been working in the VR and AR space for the last several years at this point. The channel and YouTube community naturally started around the concepts of VR and AR and building tutorials and prototypes to help more developers get into that space. In the past year or so at this point, I've gone ahead and started taking a look at what it would mean to integrate with Web3 and Ethereum and the blockchain in general. I've been kind of looking at the space since 2017, but I thought there was a natural fit where I thought it would be really interesting to bring in some of the economic principles, primarily at that time it was around DeFi, to the VR and AR space and kind of bridge that together in what's now known as the metaverse. At the time I was creating those videos, that term wasn't really in the mainstream, but it's exciting to see that that kind of has taken its own theme, even if I might not necessarily like the term itself. So over basically this past year, I've been creating a lot of videos and content to help more indie developers approach the space, because the reality is of it that it's an incredibly complicated field with a lot of nuances and a pretty steep learning curve, if you ask me, with not a lot of tools that really support game developers and primarily indie developers when it comes to entering the space. So my hope is to help educate more people getting into the space, help point towards the right tooling to get into the space. And as we go throughout this talk, you'll see plenty of videos that I've been putting together for the last several years that I'm going to be pointing to as resources that, while naturally everything in Web3 constantly evolves and changes, some of the core principles still pretty much remain the same, and hopefully those still act as good resources as you're going through and trying to build out your games on Web3. So with that, hopefully explaining kind of what FusedVR is and what the motivation is, let's dive into some of the key principles. So I think one thing to maybe set the stage here is that game development is complicated. I've gone ahead and posted here several games and just approximately the timeline that it took for them to go ahead and build out the game, from a bunch of different genres, right? From 2D to kind of more expansive MMOs to kind of very more traditional indie games like Fall Guys. All of them naturally are kind of falling within that 2 to 3 year time window on average for development. And that's without Web3 for the most part. When you start looking at Web3, unless you really know what you're doing as an indie developer, I think it adds a big layer of complexity when it comes to actually making sure you can deliver on a very fun game while still maintaining the whole Web3 stack that we're going to be taking a look at in just a second. And that really will sink into your time when it comes to development, because the more time you spend on the Web3 aspect, the less time you're going to be able to spend on the game development aspect given the same budget, which is a complicated paradigm. And so as we go throughout this session, I want you to keep this time frame in mind, that you are roughly looking at a 2 to 3 year time window for developing games. And given that a lot of that should be really developed on the core gameplay mechanics, the fun, basically pretty much everything that most Web3 people complain about Web3 games, which is that they're not really that fun. If a lot of your budget goes into that, you need to start thinking about what is that Web3 stack. Try to simplify it as much as you can to really make the most get the most value out of your time developing games. So at a very, very high level, there are a bunch of different layers to the stack when it comes to Web3 development. And we're going to be walking through a lot of them in more detail as we go throughout this talk. I've gone ahead and summarized that together in a video that I literally am putting out the day that this session is going up, called Getting Started, Your 101s with Crypto. And again, similar to this talk, it is a summary of all of the different videos that I've compiled over the last year, basically, really walking you through end to end on all of the different steps that are needed to get into the space. But at its core, when you really break down blockchain and game development and what that really means, there are kind of 5 key layers of this stack. So one, starting with wallet authentication, being able to connect someone's wallet to a game. While that might sound incredibly trivial, it is a lot more complicated than it actually leads you. And you can spend a lot of time, if you don't have the right tooling, just building out custom solutions to just try and read the state of a blockchain or try to verify that someone says who they say they are. The last thing you want to do is, in your game, give out NFTs to players and then allow players to hack the fact that they have NFTs when they don't really say they do, just because you weren't able to authenticate the player. So by you leveraging wallet connection authentication solutions, you'll be able to prove that a player has the NFTs they claim to have, and as a result, can use them within the context of your game. The second layer to blockchain development is something I think a lot of people get started with, but I actually will touch a little bit more on this topic later. I think it might be a little bit more nuanced is smart contract development. And there's a lot that goes into that specifically as well. And we'll walk through, I think, a really interesting example use case of something where I think you might want to think twice about doing smart contract development. The middleware layer here is around blockchain nodes, which are those nodes that act as decentralized points that you can communicate with. They are, in the case of proof of work, the nodes that are going to be doing the mining or validation of your transactions that are happening on the blockchain. And having a network set up for them is incredibly important for interfacing with the blockchain. Then we finally get into the bottom layers here, which are your integrations with your game, using SDKs and tools and APIs to go ahead and run and verify anything that you want from the blockchain. And I think from a anti-cheat perspective and server authority perspective, you'll need a backend that supports all of this, not just from the blockchain side, but also just supporting your game in general. And we're going to see how all of these things play a role in creating blockchain games, and why they're critical and how you can start thinking about simplifying them. So first things first, wallet authentication. The key question here is, how do you let players connect the wallet to your game? There are several different solutions here, and I think as an industry, there hasn't been really that much thought put into this, and I think we're still working through a bunch of different solutions that don't have really clear standards. So from that standpoint, I think there's a huge opportunity here to actually really innovate on this space. But at its core, it fundamentally starts with the fact that your players will have wallets, whether that be MetaMask, which happens to be the most popular at this time at the very least, Coinbase, Neuron if you're on Nervos, and they all can be represented on a bunch of different devices. If you're on mobile, that's going to be your iOS Android device. If you're on a browser, that's going to be a Chrome extension or a Brave extension or Opera extension. So you have a very big device paradigm of devices that any player would be willing to connect from. And we're kind of keeping a little bit of a focus here towards EVM and that ecosystem because just it happens to be the oldest in the space. And so naturally a lot more work has been put into it compared to other wallets in the space. But eventually I think over time you'll start to see other wallets that start to compete and have their own protocols as well for interactions. Now, the challenge here is that if you're building a web game, for example, it's fairly straightforward to go ahead and then connect through JavaScript to the various different wallets that happen to be browser extensions through the Web3 JavaScript APIs and SDKs, and that typically works fine. But the reality is most gamers today end up going through a mobile app or a desktop app. And in the case of mobile, you might not have a player that is actually using or maybe put it another way, if it's a mobile app, that wallet may or may not exist on that same device. And it could exist on some other device. it could exist on a browser, for example. And so it starts to become a little bit more complicated in the case of mobile, where how a player actually ends up authenticating with your game. The side is also true for desktop applications, and in fact, probably a little bit more complicated. Similarly here, your desktop application might want to connect to a player's browser-based wallet. And there aren't that many good solutions that are there for that, because there's no real core bridges that exist between browser-based wallets and desktop applications, even if they happen to be on the same device, because they still are treated as two separate entities by the operating system, and thus are not really allowed to communicate to each other without going through some sort of networked solution. And the final layer to this is that you could connect a desktop application to a mobile wallet. And that's where some solutions like Wallet Connect are really trying to bridge the gap here by enabling you to take your mobile wallet, scan a QR code, and using that QR code, then have a WebSocket bridge that interfaces between the two devices so that you can start authenticating with transactions. But I think the challenge here, again, is that it assumes that you are using a mobile wallet, which may not be the case for all of your individual players. So when you're thinking about it, it becomes very, very complicated and a giant mess of schemes on how you might want to do it. And so from my perspective, what that really tells you is that you actually want to be reading the state of a blockchain from your game, but you don't necessarily want to be writing to the blockchain from your game, because as you write to the blockchain, what ends up happening is that is what really requires you to have that interface between your game and your wallet that's happening all the time. And just by the way the tools are working today, that's may or may not be always feasible. But it's fairly easy to read from the blockchain. And that is, I think, the important takeaway from this is that, yes, you can use tools like Wallet Connect, but you don't need to use tools like Wallet Connect if you've just done the authentication and you can read to the blockchain. So that's one layer of things that you can take a look at to try and simplify your development when it comes to building games, using that constraint as a means to actually go about simplifying how you actually interface with the blockchain. So that's something to think about when it comes to wallet authentication. Moving down that stack, the next topic you might want to take a look at is smart contract development. So I did just explain that you might not want to be reading from the blockchain, but what if you are in that case of, or sorry, I should clarify. I might have just said that you don't want to write to the blockchain, but let's say you're building a web game, and so writing to the blockchain isn't a big deal. And so you go about the process of trying to develop a smart contract. So in this little exercise that I want to put together really quickly, I've gone ahead and thrown together an example smart contract on screen. And just to quickly summarize the example here, it's a function. It expects a payment of Ethereum of 0.5 exactly. And that is the only acceptance of payment that happens to this function. And each run, it'll eventually sum up all of the 0.5 payments, and then at milestones, so examples of like milestones being like 1, 2.5, 5, Ethereum, for example, it's going to do a payout. There's a vulnerability with the smart contract, and this should fully encapsulate it here, and it's on a specific line, and so I'll maybe give you like 5-10 seconds to quickly digest and see if you can spot where that vulnerability might be. And if you're watching this in a video format, feel free to pause the video here, take a look, and take a guess. So the problem with this smart contract actually happens on line 14. And it is with the this.balance call in particular. Now, if you're not familiar with what this.balance is, you might have been able to take a quick guess at what that is. And it is basically for the smart contracts, it tells you the balance of the Ethereum within that smart contract. might make sense given the kind of payout scheme that's happening here. And again, because we're expecting the payments to come in 0.5, it should always be that the milestones were set at multiples of 0.5, and so everything should have been fine. But the reality is this dot balance is a little bit tricky because it can be manipulated from outside of the smart contract through what is known as a self-destruct function. So I can basically go ahead and create a smart contract outside of this smart contract in which I, let's say, put 0.1 Ethereum into that smart contract. So so if I have smart contract A, which is the play function, smart contract B is a smart contract that has zero. I just put in increments of say 0.1, or I can just deposit however much Ethereum I want into it. So let's say I deposit 0.1 Ethereum into it. I can then call the self-destruct function of any smart contract. So in this example, I'm going to self-destruct the 0.1 smart contract. What happens when I do that is I have the ability to send that Ethereum anywhere. And the reason this was implemented is just so that you don't have a case of lost Ethereum that's stuck in smart contracts. So it's kind of more of a safety mechanism. But the challenging here part is because I have the ability to transfer the Ethereum locked within the smart contract anywhere, I can transfer it to another smart contract. So if I transfer that 0.1 Ethereum to this smart contract, the balance will actually become, let's say there was already an existing 0.5, it'll become 0.6. And because each of the balance checks are by equal signs, it will never actually hit any of the milestones anymore. And so that's a very, very sneaky way and just, I think, a very digestible example of some of the many, many nuances that you can run into when it comes to smart contract development. And it's just incredibly nuanced when it comes to all the various different vulnerabilities that exist out there within the Ethereum ecosystem. I've linked at the bottom here just an example of where this function is coming from, but there are a lot of other things that if you Google learn from like reentrancy, for example, to many others that if you're not very careful with how you develop your smart contract, you are likely to run into major vulnerabilities, and that is a huge, huge problem. And especially when you scale, if someone finds this, that could potentially ruin your entire game. So in that regard, really, I just generally recommend if you're getting started in blockchain and indie game development for Web3, keep it extremely, extremely simple. You can write read functions onto your smart contract, so echoing off of point 1 around wallet authentication, that simplify your development. So in the video that I've linked here, which is viewing player NFTs, I put in a couple read functions to make it easier to pull the NFT data based on what NFTs a player owns, which is great. I'd also recommend if you are going to write to the smart contracts, really try to stick to the Open Zeppelin standards. I think they're an amazing resource that has a lot of audited smart contracts that can be used and with really relatively professional functionality, from burning, minting, administration layers that are not really part of the standards, but at the same time are still really powerful. And again, all of this code is audited to make it really, really easy to use. And like I said, Open Zeppelin has the standards for ERC20s, which is your tokens, 721s, which is your NFTs, and 1155s, which allows you to have the flexibility of creating tokens that are either NFTs or fungible tokens. So just starting here, I think, is really, really powerful, and trying to limit yourself to this will help you go a long way without introducing vulnerabilities, which I think is the key part that you really need to worry about when it comes to creating in this space. Moving on, let's just explain what blockchain nodes are. Blockchain nodes, I think, are an incredibly key aspect when it comes to blockchain development. If you've just gone through the baby steps of actually just playing around with wallets and doing transfers and interacting with applications, you may or may not have actually been aware of the fact that you are really talking to a blockchain node. But a blockchain node is really just a node that is connected to the blockchain, that is validating transactions, that allows you to submit transactions into the blockchain. And when you have a MetaMask, Infura is actually the back-end service provider that is powering all of those different transactions that you're actually able to do through the blockchain. And that's incredibly powerful. It's basically acting as that server bridge for your wallets to start interfacing with things. And there are a lot of different services that are out there. I've listed a couple of those logos here. Infura is a great one. Moralis I really like a lot. And those are just examples of services that you could use to quickly get access and read state from the blockchain. And again, you might be seeing a theme here that I really recommend for game developers, that reading from the blockchain is the right way to go about actually making sure that your games are designed in such a way that it is almost seamless and really easy for both your players, but then also for you as a game developer to really focus on the game itself and using that blockchain as almost like a database storage layer for your games and applications. And I think and all of these different service providers provide various different functionalities, so you can take a look at each of them. I think so, like an example like Moralis is pretty cool because they provide APIs on top of just their node providers, so that you also have very easy ways to, say, for example, get the NFTs that a player owns, which might not always be obvious because of the fact that NFTs can be stored across a wide range of contracts. So it's not just as simple as querying the blockchain to find out the state of a player's NFT ownings. So that's something to keep in mind here. If you want some example use cases of that, you can take a look at this video that we did with an Ethereum, which will show you setting up Infura and then connecting that to your Unity SDK via an Ethereum, and using Infura in this case as a means to read the state of the blockchain and interact with it. Moving again down the stack here, we have client SDKs and APIs. There are starting to become more and more different solutions that are existing on the market when it comes to making your life as a game developer easier and more convenient. The challenge is that because of the problems around wallet authentication, some of them are probably better than others and have their own pros and cons. I've listed a couple of them that we've taken a look at on the channel, more and more naturally kind of popping up as we move along in the space, which is really exciting. ChainSafe, for example, just moving down the list here, is a pretty open source project that I think is really optimized for the web experience when it comes to deploying a WebGL application and making it easy for you to have APIs to read the smart contracts of various different tokens. And they have a focus primarily on trying to make it as decentralized as possible so that your clients are actually going ahead and just talking to the blockchain without any really middleware in between. They do have solutions for standalone and mobile, but I think there's still a lot of work that needs to be done for a truly decentralized use case where you don't need a server in between, so that you actually just go client to blockchain. But that said, I think overall it's still a pretty powerful SDK that's available in the market today. The other one that I mentioned before is called an Ethereum. An Ethereum is a really powerful C# SDK that they have also gone ahead and made available through Unity. It doesn't really provide any of the tooling per se when it comes to actually going in and connecting to a wallet. However, it does provide that base layer of code to make it so that you can call smart contracts, call and talk to the blockchain if you have a private key, or if you just have to publicly easily read the state of smart contracts on the blockchain, or any data that you want associated with that. And then from the FusedVR perspective, we've been working on our own APIs to make it possible to easily authenticate from a game developer's perspective. So making it so that you just call a single login function, and in doing so, you'll be sending out an email to the player. The player can go ahead and open that up on mobile. They can go ahead and open that up on the web. So really solving for that device use case here. And then based on what device they open up that email on, they will then be able to authenticate their wallet. This provides that security when it comes to verifying that a player is who they say they are, and also makes it relatively seamless for you to connect that wallet to your game. And then from there, you can call whatever APIs you want. As I mentioned on the Morales side, for example, you would be able to call, say, get all the NFTs for a player. So now you have a authenticated user to your game that you have gone ahead and verified that they have the NFTs that they say they have. And so now you can define your game based on any of those parameters. And so I have some of those APIs that are exposed through the FusedVR SDK, but then you can also pair that up with Morales, which has their own Unity SDK that you can start plugging into, which I think is incredibly powerful for things like you say you might want to listen to events with a database. Morales will allow you to do that with the blockchain, which I think it's worth definitely taking a look into. So you have a bunch of different tools. The theme with most of them is that I really don't recommend reading to the blockchain. I'm gonna beat that like I hammer throughout this session. Is if you're really looking to simplify your experience and really try to just focus on having your game be pretty seamless for your players, reading from the blockchain I think is really the place I would recommend starting with in the development of any game that you're working on. Oop. I'm gonna move through all of these videos, and you get to see me on all of them. The last topic that I would want to touch on is around game server authority. Now, we've touched a lot about reading from the blockchain, but let's say you want to reward players not by having them write to the blockchain, but having your servers write to the blockchain. So this is a very common use case with play to earn, for example, where let's say your players have gone ahead and beat a boss in a game and you want to reward them with a token. Your server would be the one to send that token to the player because you already know their wallet address because they would have authenticated with you. The challenge is, how do you know that the player actually beat the boss? And what happens if they didn't beat the boss? Then you have an open question of basically cheating that's happening in your ecosystem. So there are probably a few different ways that you could check for this. If you really want a very seamless maze of actually validating that a player has defeated a boss like they said they did, you would basically want to take all of the input from a player, verify that on a server that you own, and then based on that verification, if they did indeed beat the boss, you can award the token. And so it creates this client-server blockchain architecture that you can use for going and verifying actions of a player and then rewarding players for that. And PlayFab is a really great tool that exists today that allows you to do that authentication. You would basically, from your Unity game, Unity mobile app, whatever, you would send the player's input to PlayFab. It would spin up a server that's going in and validating the state against your game. And then on a win state, the server then goes ahead and submits the verification to the blockchain, which rewards the player. So by doing this like three-step layer, you've gone ahead and added an anti-cheat system, which then makes the economy much more resound in the fact that no one's going to be able to hack your client and then as a result potentially ruin the whole economy of your game. And I think that's an incredibly important aspect that not many people think about when it comes to building out blockchain games. And it really comes down to how you want to structure the economy and how you want to reward players for certain actions, which you have to do, but I think is very different from writing to the blockchain. This might be a case where there is a lot of complexity that happens to it, and if writing to the blockchain is incredibly important for you, you would want to focus on this type of a use case. But if it's not that important to you, then it might be something that you want to scrap in together and really just keep your core focus to reading from the blockchain. So those are the 5 layers of the blockchain. There are a lot more nuances and details that you could dive into as you're going through any of these steps. But really, I would try to simplify each of these steps as much as possible. And again, I think the core theme here is from reading from the blockchain. The more you can read from the blockchain, the less you, and ideally not at all, write to the blockchain for your game, the simpler your end user experience is going to be, the simpler your game development experience is going to be, and reducing the scope in that way across all of these different 5 pillars is really going to save you time and energy and allow you to focus on your game and make it fun and make it enjoyable, because at the end of the day, that is really what the players want, is a fun game that really focuses on them, provides them that entertainment, and then all of the blockchain layers on top of that are really kind of nice to haves that ideally make it simpler for your players to identify and claim who they say they are, take their identity across games and the concept of the metaverse, but then also be rewarded for any maybe potential key actions here. So again, maybe to quickly summarize it, right? It is wallet authentication, smart contracts, blockchain nodes are those servers. You have your SDKs that are out there to try and make your game development simpler, and then that server authority aspect. So that I think roughly covers the 5 things that I wanted to talk about in this session today. I hope you all enjoy, and I hope this is helpful to set some context on what goes into developing Web3 games and how you can really start thinking about simplifying across any of these 5 layers. So thank you so much for your time, and have a great rest of the BlockJam.